This is the Visual Studio 2013 solution for the project, containing all of the classes and functions used. The file pluginmain.cpp contains two functions, initializePlugin and uninitializePlugin, that are called by Maya when the plugin is activated and deactivated. Unfortunately, I don't have time to go into any more detail than that within this video. The project builds as a .mll file, a Maya plugin file, which is basically just a renamed dynamic link library. The MLL is called procedural walking. The plugin has to be activated using the plugin manager before any of the commands that it adds can be used. The update walker command is the command that moves the walker forward along its local x-axis and updates the feet to correspond to where they should be. The update walker command could be used as part of an expression, but here I'm just repeatedly calling it from the script editor. The stepping algorithm is naive and doesn't recast against the geometry in front of it to figure out how high it should raise its feet or anything like that. Unfortunately, I didn't have time to add very advanced controls. I'd like to add a way for the user to define an XZ direction vector in which to have the walker move, among other things. As you can see, it sort of takes very short steps, and the order in which it takes them isn't ideal. And this is what happens when it reaches the edge. So the hierarchy looks like this. The CTRL root is the parent of the root joint of the skeleton. And it is also the parent of these things, which are locators, which indicate where the feet are trying to get to. The CTRL root control shape is constrained to the terrain, or the ground, or whatever you want to call it, by a normal constraint. Each of these foot control shapes has is the parent of the IK handle for that leg. CTRL root has a pair of modifiable keyable attributes which control its speed and the height of steps. In this test, I have removed the line of code from the plugin that moves the walker forward, and instead I'm using Python to rotate the walker around the y-axis and then to call update walker, and it sort of works. In this test, the ground plane has been replaced with a sphere. I had issues with getting the raising and lowering of feet to work in this setting, but once I fixed it so that the feet moved upwards along their own local y-axis rather than in world space, it worked as it should, allowing it to step correctly even while upside down. It needs work and requires many additional touches, such as having the body bob up and down as it moves, and of course enabling more control without having to edit the code. The algorithm is very simple, and I'd like to try to get it to work in real time in a fully interactive manner in a game engine such as Unity. The trickiest implementation detail would be getting IK solvers to work. I'd have to look for some kind of library which would handle that side of things. Anyway, thank you for watching.